Close your eyes, guys, and open them again. Is the world you see being created by the reason you see it? Is your consciousness playing an important role in creating this world for you? Well, it's a very strange, even complicated thought. But then why is it that the founding fathers of quantum mechanics, who have made this the most successful theory in the world today, they all used to think exactly this way? They all used to believe exactly in this idea. Well, even in ancient Vedic philosophy, Vedanta philosophy, the universe has been called illusion. So, has the time finally come when science and religion finally become one? Well, you will get the answer to this very soon. But first, let's understand, why did the scientists of quantum theory believe in such a supernatural concept? Because generally, as you know, science does not believe in supernatural consciousness or spirit-like things. So, has any mistake been made by these scientists? So, to understand this, we have to start from the beginning of this whole mess, which is the most powerful and miraculous experiment in history, the double-slit experiment. Now, many people must have heard about this experiment many times, but trust me, there must be someone who understands every secret of it. So, we will publish this experiment once and for all, with its proper interpretation and understanding in your mind, because it is the backbone of quantum theory. And it also proves that the reality, that is, the things happening around us, the things that are present, that we can see, all of this is a specific illusion. Once again, the quantum theory fathers believed in it. A few centuries ago, the situation was such that some basic things of the universe, all the great physicists, were confused about its light and its nature. They were not able to understand that light is a particle or a wave. That is, it behaves like a particle in nature, or like a wave. Now, my scientific-tempered friends, as you know, experiments have the greatest importance in science. Experimental results are given the most weightage as evidence. And experimentally, whatever experiments the scientists were performing, the same thing was coming in front of them, that this light is showing duality. That is, at the same time, it is acting like a particle and acting like a wave, as if at the same time one coin is showing two sides. That is, at that time, there was such an environment that, let's say, if one physicist is saying that your shirt is white, then the other was saying that, seeing the same shirt, it is black. And not only saying, but also proving in the form of experimental results. So, how can one thing have two different natures? Well, to understand this, we have to understand what the scientists saw in those experiments. So in the late 17th century, scientists were divided into two groups, Group A and Group B. Among them, Group A, who believed in the Newtonian concept, they believed that light is a particle. And Group B, led by Dutch physicist Christian Huygens, they believed that light is a wave. And both had solid experimental evidence. Now, the leaders of both these groups, i.e. Newton and Huygens, had given their theories at about the same time in the past. But because Newton was a prominent physicist of that time, for the next 100 years, mainstream physics accepted his particle theory. Now, this claim of his became weak when in the early 19th century, one after the other, two such experiments were conducted, which proved light as a wave. The first experiment was done in 1804, when British physicist Thomas Young, for the first time, through a double-slit experiment, showcased the destructive interference pattern of light. And the second experiment was done in 1819, when French physicist Franco Arago, through his Poisson spot experiment, showed the constructive interference pattern of light. Now, this constructive and destructive interference pattern is formed when two waves, respectively, either merge or cancel each other out. That is, they are created by waves. So, because of these two experiments, Christian Huygens' theory finally got limelight. And due to his score of 2:0, Huygens' wave theory ruled for the next 100 years. So, the score was 2-0 till now, right? But the picture is still there, friends. Now you have to see how the particle theory covered it up. So the 20th century came after this, and at this time, 2 such experiments were conducted, which even unwillingly brought Newton's particle theory back to life and brought it to limelight. The first experiment was done in 1905, performed by one and only Einstein, which is called the photoelectric effect, in which he showed that light collides with electrons in the form of particles and throws them out of its atom. And it can throw. So, there is an interaction, which can only be done by a particle. And the second experiment was the Compton scattering experiment of 1923, in which physicist Arthur Compton demonstrated that X-ray light transfers its energy to it when it collides with electrons. So, yeah. After these 2 demonstrations, now Group A and Group B had 1 theory and 2 experimental evidences, and therefore the score was now equal to 2-2. Now, all they needed was a tiebreaker. For the next few years, a lot of effort was made to find this tiebreaker, but a solid tiebreaker was nowhere to be found. The arguments and experiments on both sides were quite strong, and the experiments to support both theories would get the same results even if they were stopped multiple times. This means that there were no mistakes in both the observations, and that's why finally, at last, all the physicists unanimously agreed that light probably shows dual nature. Light is dual. At the same time, particles and waves exist in nature in the form of both of them. Now, this belief was a major turning point in the world of physics, because here, the first chapter of defining the reality of this universe ended, and physics finally moved on to its second chapter, which was understanding matter. Till now, we had talked about light, right? Now it was time to understand matter, particles, atoms, quarks, electrons, etc. So, scientists had understood that light shows dual nature. But after this observation, physicists started thinking for the first time that what if in Einstein's photoelectric effect experiment, the photon knocks out an electron? What if it also shows a mixture of a wave and a particle, or dual nature, like light? Because in 1924, that is, right after Compton's scattering experiment, famous French physicist Louis de Broglie hypothesized that if light can show wave-particle duality, then why can't normal matter and all its particles and subatomic particles show this wave-particle duality? What crime did they commit? Smart thought, right? So, in 1927, 2 American physicists, Clinton Davison and Lester Germer, decided to test this hypothesis. And through their famous Davison-Germer experiment, they experimentally proved that whether it is light or matter, i.e. electron, quarks, and all particles, on a quantum level, all things, indeed, also show the nature of waves. So they act like waves on a quantum scale. Now, I don't know if you can imagine this dilemma or not, but in those days it was like a bomb blast in the minds of scientists. Just close your eyes for a few seconds and imagine yourself in the place of Broglie. Imagine that on one hand, you know for sure that you can touch the things around you. You can feel them. And yet, experimentally, it seems that all those things are actually not made of solid particles, but made of waves, which cannot be touched because they have no definite position. They just have a possibility of meeting in one of the other locations. And then, from here, an obvious implication came out that perhaps, on an ultra-microscopic quantum level, the world works in such a strange way, but from that quantum level to our macro world, while coming with the waves of all particles, something is happening that they are giving up their wave nature and are transforming into a definite specific reality. But no one knew how this was happening. To explain this, no one had any idea, no theory, and this exact thing was going to be the biggest question of the scientists of the world for the next 100 years. Now, friends, I am sure, even you, if you ask this question to any of your science lover friends, there is a good chance even they will not know this. But don't worry, you will know this today. So, watch this video till the end, because it is a very interesting concept. I will reiterate again on an ultra-microscopic level how the particles are behaving like a wave. That is, they don't have a fixed location, they can be anywhere. But, on a macro level, they are acting like proper, definite objects. That is, you will find them at a particular position. It is not that they keep changing their location like waves. So, how is this conversion, this wave function, transforming into a particle nature? Well, run your mind till then, you will get the answer to this very soon. But let's move the story a little further. Scientists found it so complicated to convert this wave nature into a particle that it was like a product of an illusion. And that is why, to digest this fact, many scientists took the help of philosophy. And then, the same episode starts, when scientists like Schrödinger and Heisenberg were inspired by Hindu philosophy, where something is created by illusion. This was discussed, Vedant philosophy. But friends, till now, don't draw any conclusion in the story, because the story is not over yet. This is not a take-home message, that everything is created by illusion. Later on, we will find out what real suspense is, because here many fathers of quantum physics were not able to interpret it properly. Which today, just because we have modern technology, that is why, you will be able to know more than that. But anyway, coming back to the scientific community, so, on one side, where the experiment of Louis de Broglie was proven right by the Davison-Germer experiment that yes, subatomic particles also act like waves on quantum level. On the other hand, three prominent founding fathers of quantum physics, Niels Bohr, Erwin Schrödinger, and Werner Heisenberg, were not that happy with their stance at that time. And that's why they invented a mathematical formula to study this wave nature in depth, called wave function. So now, it was time to study those quantum waves so that we get more information about their behavior, for which they took the support of wave mathematics and invented a new concept called wave function. But in those days, Heisenberg separately, along with his mentor Niels Bohr, were looking for it with a lot of impatience. They felt that Schrödinger's wave equation has described the wave nature so well, and we have understood a wave very well. So then, why does that wave collapse, and how does it happen? Why is it not visible? Are we missing any important thing? So after thinking for many days, Niels Bohr and Heisenberg realized that, somewhere, the answer to this can only be given by a double-slit experiment. And that's why, this time in the double-slit experiment, they tried to add a new twist, a new angle, and think about it. This time they did a thought experiment, that what if, in this double-slit experiment, we use a detector to keep an eye on those photons. So in this case, maybe our active measurement will force the wave nature of a particle to change into reality, that is, to change into particle nature. Because observing something or detecting something is to be measured by ourselves, for which we have to interact with something, right? I mean, when you see something in the dark, then what happens? You hit a torch on that thing, by which the photons coming out of the torch hit that object and transmit its information to the retina of your eyes. So, maybe, in the double-slit experiment, this detector will definitely interact with those particles, and because of this, the wave function will collapse. Now this very idea, developed thoughts from it, and its countless versions, were later named the Copenhagen interpretation. Since Heisenberg and Niels Bohr, all these discussions originally took place in Bohr's hometown, Copenhagen, when Heisenberg went to meet him there. Now, from this idea, some very weird conclusions came out. Many mystics and supernatural gurus started writing books that see until you don't see things, until then, it doesn't exist. Everything is just an illusion, and your soul, your consciousness creates the universe, which doesn't exist. Now, you too, maybe, have seen many such videos, which say that quantum mechanics says that by seeing, reality is created. But, the picture is still remaining, my friend. This is a completely wrong interpretation, and soon you will know why. But at that time, even our Einstein brother found this idea very strange. And in fact, this is the reason that in the late 1920s, he made Niels Bohr that famous taunt. Do you really believe the moon is not there when you are not looking at it? And Einstein was a big opposer of quantum mechanics. He didn't agree with the thought experiment in Niels Bohr's double-slit experiment, even though Niels Bohr mathematically backed everything. At that time, there was only one thing missing, and Einstein would have got the solid proof of this observation. And that thing was to perform that experiment with a detector that would be used to perform the experiment. At that time, technology was not so advanced that they could make a precise detector. That means, if we look at it from one side, then in today's date, you have the opportunity to understand quantum mechanics more accurately than their founding fathers. Heisenberg, or Niels Bohr, or even Schrödinger could never do these experiments, which could give the correct interpretation. They themselves were kind of confused. They were finding the observations to be weird, but they were not able to understand the meaning behind it. But today, with just this one video, this historical confusion of yours will be cleared. Because, moving forward, this updated experiment of wave function collapse was practically explained by German physicist H. Dieter Zeh. When he, in 1970, practically performed the double-slit experiment in real life with a detector and presented his observations and conclusions to the world. His experiments told us that the thing is that whatever nonsense we have made up in our minds about the waves of matter, that how waves are, how they collapse, and how they create reality, all of this is a stupid interpretation. Dieter Zeh and the similar experiments in the 80s pointed to one thing, that in quantum mechanics, this confusion is created entirely because of two words, and that word is wave function collapse. Instead of this, if we use the word quantum decoherence, then quantum mechanics suddenly becomes clear like water. So clear and simple that even a child can teach it to 4 people. Actually, in the year 1926, when Schrödinger gave his equation, at that time, a German physicist, Max Born, to explain the meaning of that wave equation, he invented the famous Born rule. According to this Born rule, the interference pattern that we see on the screen does not mean that particles exist in the universe as a fluid like water. It simply means that just like all the H2O molecules of this flowing water move up and down at the same frequency and move forward similarly, coming out of a particle beam, propagate at the same frequency, and move to the screen. Now, with this kind of movement, it is obvious that there will be an interference pattern on the screen, because they are propagating like waves, in which, by using the Schrödinger equation, the individual particles of the original wave will collide with each other. On the screen can be predicted. But if we put a detector, let's say, near a slit 2, then what will happen? Obviously, that detector will shoot photons on the particles coming out of slit 2, so that like a ship's sonar system, it will bounce and come back and give us some information about those particles. But in this detection method, there is a fundamental flaw, which I am sure you all had missed, but not today. Today, the hero of our picture whose name is quantum decoherence. Now, quantum decoherence simply means that the wave motion of the particles breaks in sync. Going out of sync, its coherence breaks, that's why the name is decoherence. So, since those particles can randomly collide with our photons at any angle, then obviously their flow will get spoilt. They will collide at any angle on the final screen, not in a proper wave interference pattern. Secondly, since due to this collision, some of the energy of those particles will get transferred to our photons, so therefore the frequency of the particles in slit 2 will go out of sync. So both position and momentum have been affected. And that's why, in the end, we won't see a parallel sync interference pattern. Meaning, we have ruined a perfect wave pattern by using a detector. So, the particles on the final screen, which were showing an interference pattern just because of that detector, will show a non-interference pattern. So now, tell me, why unnecessarily, or spirituality, or soul? Clearly, only the mathematical wave function is collapsing, because with the help of that, Now you can't predict on the screen which particle will go where and collide. You have ruined the wave behavior with your own hands. Now friends, notice one more thing here. Earlier, we were seeing multiple patterns. Now they have been localized. And what is a particle? It's localized energy, right? And see, this is your particle conversion from wave, quantum decoherence. Now, why is this happening? Let's understand this in a little detail, because I know you might not have got satisfaction till now. Along with this, let's raise another big question, that why is it that quantum objects behave like waves, but big objects don't? Well, for this, how quantum decoherence is happening, that has to be understood. So imagine a totally empty space. In this you have shot photons, then electrons, and then quarks. Now, every particle has its own individual wave function, which has its own frequency and wavelength. Now, there will be two things here. First, there will be quantum entanglement. That means some particles will start sharing their wave functions. And second, because of so many interactions, their wave properties will start changing. All the waves, which were in sync in the beginning, will now start getting out of sync, and this is called decoherence. They have lost their coherence, that is, their sync. Let's understand this in a way, and now, Navratri is also going on, while playing Garba, how dancers start in the same sync, and then, over a period of time, all their steps get out of sync. And this is exactly what happens with the quantum system. And when the wave functions of the different particles of the quantum system get desynchronized, then because of the loss of sync, mathematically, the value of the quantum system will cancel out each other, and a single net output will be generated. And this is the reason why big objects never behave like waves, because they have so many atoms that the frequency of all the atoms can never vibrate in the same sync. It's just next to impossible. If we take the example of a tennis ball, then there are 10 quadrillion atoms in it. Do you think all these atoms can achieve the sync of the same wave at the same time? How many things are interacting with the atoms in the environment that will easily desynchronize the sync of their waviness? It's like if you start 100 clocks at the same time, and then someone comes in between and keeps on disturbing them, then all of them, after some time at the same time, will show the same sync. And that's why big objects don't always show the wave property, but show the particle properties, because their wave nature, due to decoherence, has averaged out and turned into a particle nature. But in principle, it's absolutely possible that if you can somehow bring all the 10 quadrillion atoms of a tennis ball's wave functions in unison, that is, in one sync, then that tennis ball will also start showing the properties of the wave, meaning it will start behaving like a quantum object. In fact, scientists have practically done this with some molecules, which had hundreds of atoms. Crazy, right? But in the case of a ball, it's just next to impossible to do that. But if somehow this happens, then another restriction comes, because of which, still, we won't see the ball changing positions like a quantum particle. And that is because of de Broglie wavelength equation, which is this. Wavelength is equal to h divided by mv, which basically tells us that as the mass of an object increases, its wavelength will decrease. So in the case of a ball, this comes out to be 10 raised to the power of minus 33 meters, which is the distance of a proton size. No one can notice this. So yeah, even if you bring all the tennis ball's wave functions in sync, then the tennis ball will take the wave properties, but you won't be able to notice its waviness. You won't be able to notice its wave nature. And because of the restrictions of this universe, the quantum world will look different to us, and the classical world will look different. These restrictions are the barrier, which will always keep the quantum world separated from the classical world. Just majestic, right? And you have also understood that this wave function of collapse, or quantum decoherence, is a completely physical and logical process, and not a supernatural process that your soul or consciousness is doing. In actual reality, particles naturally vibrate because of their energy. In fact, scientists understand this decoherence very well, so much so that they have tried experiments of recoherence and have also successfully done it. That is, first of all, quantum decoherence was done in the middle of a limited number of atoms, and then kept an eye on individual wave functions to see how they are changing, and then made their wave functions coherent again. That is, made them vibrate in the same sync, in the same frequency, so that they were waves in the beginning but became particles, and then became waves again. Now, this experiment is mind-blowing, right? This shows that we have also started to understand the quantum world. But anyway, friends, the joy today will be that you have finally understood that what is quantum decoherence? What is wave function collapse? How is matter created by illusion? There is no supernatural reason behind it. This is a completely physical process called quantum decoherence. Now, I know, maybe it might have seemed a little complicated to understand, but there is no problem. You have only seen it once. See it twice, see it 3 times. You will easily understand. And then, you can also make a fool of yourself in front of your friends. If you liked the video, do hit the like button.